Hello everyone, I am Ushura. Today we are discussing about class 12 physics chapter number 12. In this chapter we will discussing about last topic of our this chapter. So first of all, it is our de Broglie explanations of Bohr's second postulate of the quantizations. So see here, what is that? That due to the second postulate of Bohr model, there is something we are discussing about in the last lecture. There is a L is equals to L it is equals to mvr, or also it is equals to nh upon 2 pi. We have told about that there is a nh upon 2 pi. So this is our second postulate of the Bohr's model. So due to the angular moment of the electron orbiting around the nucleus is quantized. So he was told about that the L is the angular momentum of the electron of orbiting around the nucleus is, and it is equals to Ln is equals to nh upon 2 pi, where h is our Planck constant. So now why should this value only, why we are taking this value only, Ln is equals to nh upon 2 pi. So this, see here, electron have a particle. We in the 11th chapter we are discussing about the electron have a two types of natures are there. It have a particle as well as a wave nature is that. So according to de Broglie hypothesis, there is a electron have a two types of nature is that. It has a particle nature as well as it have a wave nature is that. So due to this phenomena, it is represented as a lambda, it is equals to h upon mv, and see here, but here P is equals to mv. The P is a momentum. It is a momentum of the electron. Lambda is a wavelength of that, and h is our Planck constant is there. So based on the Planck and the de Broglie hypothesis, there we can understood why the physical quantity is quantized. We like a energy and momenta, because whenever it is a quantized, it means there is a energy, and the momenta will be quantized, it means there is an electron not escape from the atoms. So it means, it suppose according if we previous that what we was told about that, we are telling about that energy, it have energy is there, and due to this energy it will be going to the travel, and due to the travel it is suppose it have energy is there, and it is have a quantized energy, so it have something energy is there, so it is a far away from the atom, so it is not happening this time. So it means that our atom is a stationary atom, and it has stability is that. So due to this phenomena, according to de Broglie hypothesis, there is a, what will happen, we are talking about that it is a quantized. What is the quantized? Energy and the momenta, it is a quantized. Now see here, de Broglie associate the stationary wave because it has a wave is there, but see here, this is our nucleus is there, and it have a energy, it is our wave nature. So according to de Broglie told us that it has a wave nature as well as a particle nature. But suppose it has a wave nature, on that time it will be going look like that. But suppose it is a not a quantized, on that time what will happen, it is a very less possibility to find the exact point. Suppose there is an electron is that in the first position, on that time suppose it will be going again, and on the time, or there is a no electron is there, because there is a less possibility to find any one point of electron. So on that time what we are required, it means there is a this path is a common, because suppose it is in this look like that, so on that time it is easy. So that's why what about tell the de Broglie told us the energy and the momenta is conserved. Okay, energy and momenta is conserved. Now but we need understood due to this phenomena, in this, so due to this phenomena we can say, what we can say, the electron are, according to the mechanism, the allows only those orbital electron wave on in the, there is a circumference of the orbit is about 2 pi r. Okay, it is about 2 pi r. So on that time what will happen, so it is a multiplication of the total number of n multiplied by the number of n on the time, where is the n, it is equals to our 1 2 and 3 is there. Okay, and up to n, so n it is our 1 2 3 up to n is there. So see here what will happen, so see, when those allowed the orbital are there, it is equals to 2 pi r, it is equals to n lambda. Okay, 2 pi r, it is equals to n lambda. So see here what we are taking here, we are talking as a 2 pi r into n lambda. But we know that, what we know about that, there is a n lambda, it means See here, 2 pi r, it is equals to 2 pi r, it is equals to n lambda. But we know that lambda it is equals to h upon mv. Lambda it is equals to h upon m into v is there. Okay, so see here we are putting the value of 2 pi r, it is equals to n h upon m into v. Okay, n h upon m into v. So see here, now what we are doing, that the 2 pi m mv into r, here m 2 pi is downsides, so mv into r, it is equals to nh upon 2 pi. But we know that mvr, it is equals to our value of l, and what is the l? L, it is our angular orbital moment. So see here, l, it is our angular momentum of the orbit. So L, it is equals to mvr. So L, it is equals to nh upon 2 pi. But we know that this is our second postulate. This is our second postulate of the our Bohr's second postulate is that. So L, it is equals to nh upon 2 pi is that. So see here, what is that? It is represent the electron angular momentum. It is a quantized. It represent as our electron angular momentum. It is a quantized, and it is also gives the as a ad hoc. Okay, it is as a ad hoc. We can conclude electron have a wave nature, and Planck quantizations is consistence. What is this? Planck quantizations of energy and momenta is consistence. So according to the angular momentum quantizations and the orbital radius and the orbital motions of electron of energy is, it have a continuous is that. So that we can understood these lectures. So see, this is our 2 pi r, it is equals to n lambda is there, and what is the lambda? Lambda, it is equals to h upon mv, and 2 pi r, it is equals to nh upon mv. So see here, mv r, it is equals to nh upon 2 pi is there. So l, it is equals to nh upon 2 pi, but it is our second postulate of the our Bohr's second postulate is that. So I hope you understand these lectures, and one thing is that there is something, the model however was many limitations are there. Okay, this model have many limitations are there, but so see here, the Bohr model is applicable for to hydrogen atom. Okay, if the Bohr model, it is applicable for only hydrogen atom, but see here, it is applicable for the atom. It cannot be extended even two or more electron atoms such as a helium. The analysis to atoms with more than one electron was attempted on the lines of Bohr model of the hydrogenic atom, but did not meet with any success. Difficulty lies in the fact each electron intersect not only with the positive charged nucleus, but also with all other electrons are there. Okay, the formations of the Bohr model involves electrical force between positive charge nucleus and electron. It does not include the electric force between the electron, which is necessary appear in the multi-electron atom. Why the Bohr model correctly Bohr model is correctly particles and correctly predict of the frequency and light emitting by the hydrogenic atom. The model is unable to explain the relative high intensity of the frequency in the spectrum. So in emission spectrum of hydrogen, some of the visible frequency have a weak intensity and others strong. Why? The experimental observations found that some transitions are more favored than others. So Bohr model is unable to account the intensity variations. So Bohr model present in a elegant pictures of atom and the cannot be generalized the complex atom. For complex atom, we have used new and the radical theory based on the quantum mechanics, and which provide a more complete pictures of the atomic structure. So see here, what we have studied about that, we can due to the Bohr's atom we can only just understood about the hydrogen atom, but whenever the more than one electron on that time, we cannot give the any explanations about the this topic. So see here, whenever we require on that time, what we are using that the quantizations of the energy of topic is that. So quantum mechanics we can provide that the complete picture of atomic structure. So I hope you understood these lectures, and if any kind of comment, if any kind of doubt in these lectures, I hope you are commenting in the comment box, and you must watch this video. Okay, thank you so much guys.